Hey everyone, welcome back. In this Math 20-1 lesson, we are tackling rational expressions and equations. Outcomes in 4 and 5 and 6. If this video helps, subscribe to the channel and like the video. Today we will find non-permissible values, simplify rational expressions, multiply, divide, add, subtract, solve rational equations, and catch extraneous roots. A rational expression is a fraction made from polynomials. For example, x plus 2 over x minus 3 is rational because the numerator and denominator are algebraic expressions. The most important rule is this: the denominator can never equal 0. Whenever we work with rational expressions, we start by asking what values make the denominator 0. Non-permissible values are values of the variable that make the denominator 0. For the expression x plus 2 over x minus 3, the denominator is x minus 3. Set x minus 3 equal to 0 and solve. We get x equals 3. That means x equals 3 is not allowed. Even if the expression later simplifies, we still remember this restriction. To simplify a rational expression, factor first, then cancel common factors. Consider x squared minus 9 over x squared plus x minus 12. Factor the numerator as x minus 3 times x plus 3. Factor the denominator as x plus 4 times x minus 3. The factor x minus 3 cancels, so the simplified expression is x plus 3 over x plus 4. But x cannot be 3 or negative 4 because those values made the original denominator 0. Multiplying rational expressions is usually friendly. Factor everything, cancel common factors across the numerator and denominator, then multiply what remains. For example, x squared minus 1 over x squared minus 4 times x plus 2 over x plus 1. Factor x squared minus 1 as x minus 1 times x plus 1. Factor x squared minus 4 as x minus 2 times x plus 2. After canceling x plus 1 and x plus 2, the result is x minus 1 over x minus 2. Dividing rational expressions has one extra move: keep, change, flip. Keep the first fraction, change division to multiplication, and flip the second fraction. Then factor and cancel like a multiplication question. For example, x squared minus 9 over x squared minus 1 divided by x plus 3 over x plus 1. After flipping the second fraction and factoring, the x plus 3 and x plus 1 factors cancel. The result is x minus 3 over x minus 1. Adding rational expressions with a common denominator works like ordinary fractions. Keep the denominator and add the numerators. For example, 3 over x plus 2 plus 5 over x plus 2 equals 8 over x plus 2. The restriction is x cannot equal negative 2. A common denominator makes the problem quick. When denominators are different, build a common denominator. For example, 1 over x plus 2 over x plus 3. The common denominator is x times x plus 3. The first fraction becomes x plus 3 over x times x plus 3. The second becomes 2x over x times x plus 3. Add the numerators to get 3x plus 3 over x times x plus 3. To solve a rational equation, first state restrictions, then multiply by the least common denominator. Solve 2 over x plus 1 equals 5 over x. The restrictions are x cannot equal 0 and x cannot equal negative 1. The least common denominator is x times x plus 1. Multiply both sides by the least common denominator. This gives 2x equals 5 times x plus 1. Solving gives negative 3x equals 5, so x equals negative 5/3. Now let us catch an extraneous root. Solve 1 over x minus 2 plus 3 equals x minus 1 over x minus 2. The restriction is x cannot equal 2. Multiply every term by x minus 2. We get 1 plus 3 times x minus 2 equals x minus 1. Simplifying gives 3x minus 5 equals x minus 1. Then 2x equals 4, so x equals 2. But x equals 2 is not allowed, so it is extraneous. The equation has no solution. Here is the rational expressions and equations checklist. First, find non-permissible values. Second, factor before simplifying, multiplying, or dividing. Third, for addition and subtraction, use a common denominator. Fourth, for equations, multiply by the least common denominator. And finally, always check restrictions so you can identify extraneous roots. Like the video and subscribe for the next Math 20-1 lesson.